Alright, chemists, so today we're going to look at the molar heat of combustion. As an example, we're going to use ethanol. So what are we looking at? First off, the molar heat of combustion is essentially the heat released when 1 mole of a substance is combusted, or the energy released. Now remember, we measure energy in joules or kilojoules. This is going to be large numbers, so we're talking about kilojoules. And because it is a molar combustion, it is actually kilojoules per mole. Now, the other way to think of it is quite simply, it's the energy stored in the reactant bonds minus, or take away, the energy stored in the product bonds. So we've got each of these bonds stores energy, that's how it stays bonded. So we've got these ones here, and we take from those we take away the amount of energy in these bonds, and we see what happens. Now first, if we want to do this properly, we have to balance our equations. So that's there. For every 1 molecule of ethanol, we have 3 molecules of oxygen, 2 molecules of carbon dioxide, and 3 molecules of water. And that looks like this. So what we're actually looking at is we are looking at the energy stored in that bond, all of these bonds here, compared to the energy stored in all of these bonds. Now, if it is a delta H, let's pull up a color we're happy with. If, for example, delta H is negative, we have an exothermic. And if it is positive, we have an endothermic. Alright, so let's have a little look at our reaction here. We've got our bond energies over here. Okay, each one of these corresponds to a different type of bond. And we'll do a little bit of maths and we'll just work out what we've got. So we'll do some brackets, and it is 5 times the hydrogen and carbon bond, which is 413. And we add to this the carbon-carbon bond, which is 348. And then we add to this the hydrogen to oxygen bond, which is 463. And then we add to this the 3 oxygen to oxygen double bonds, which is 498. Now we take away from that the bonds on the other side. Okay, so we've got the carbon to oxygen double bond, and there is 1, 2, 3, 4 of those. So it becomes brackets 4 times 743, and then we go plus. Now we've got 6 of these hydrogen oxygen bonds, so it's 6 times 463. And then we go over here and we work out our answer, which is 1,000 minus 1,360 kilojoules. Beautiful, perfect, not a problem, per mole. That's it. That's your molar heat of combustion. So it's essentially the amount of energy stored in the bonds on this side of the reaction minus the ones stored on this side of the reaction. Very, very straightforward. And it's molar heat of combustion because when we set the crap on fire. Alright, see you next time.